Good day everyone. In our last lecture video, we start discussing applications of derivatives. In particular, we talk about the rectilinear motion. So for today, we're going to discuss more applications. Here are the first one will be marginal functions and the second one will be related rates. Let's start our discussion with marginal functions. So marginal functions will give us the rate of change of how a quantity increases or decreases. In particular, today we're going to discuss the rate of change of the following functions. We have the cost, revenue, profit, and price demand functions. So if you are a business or econ major, then this will be helpful for you in your analysis. We'll start with the cost function, C of x. This is the cost of producing x units of a product. So, ito yung ating gastos. Yung revenue function natin, R of x, would be the revenue in the sale of x units of a product. So, ito yung ating benta naman if we sold x units of a product. And ang ating profit function will be the profit earned in the sale of x units of a product. So, ito naman yung ating kita. And ang ating price demand function will be the price of a product if there are x demand. Okay? So, wag tayong malilito with the profit and price demand function. The profit function is given by capital P of x, while the price demand function is given by small p of x. Okay? And how do we relate P, R, and C? So, yung P natin ay yung profit or yung kita natin. So, ang magiging kita natin ay equal lang sa benta natin minus sa gastos. Okay? So, that will just be P of X, profit equals the revenue minus the cost. And moreover, yung revenue natin will be given by the total number of units sold, that's X, times kung magkano yung price per unit. So, that's P of X. Okay? Hence, again, our profit function is equal to the revenue function minus the cost function. Equivalently, that's also equal to X times the price demand function minus the cost function. Okay? Second, our cost function is always greater than or equal to 0, and C of 0 is what we call the overhead or the fixed cost. So, ito yung mga expenses natin that are not directly attributed in the production of our product. For example, kung nagbayad kayo for the advertisement of the product, that would be included in our overhead or fixed cost kasi wala naman siyang kinalaman doon sa pag-produce ng product itself. Okay? Third one, R of X or the revenue is always greater than or equal to 0, of course. And R of 0 equals 0. Syempre, kapag walang benta, wala din tayong revenue. And P of X may be positive, negative, or 0, unlike the R of X and C of X that's always greater than or equal to 0. If it's positive, then we have a gain. If it's negative, then we have a loss. And if it's 0, so this is what we call the break-even point. That's the value of X when P of X equals 0. This is when revenue equals the cost. So let's look at this example. We have a manufacturer determines the profit derived from selling X unit of a certain item. Ang profit natin ay given by P of X to be equal this expression, 0.0002 x cubed plus 10x pesos. Yung first one, we want to get the profit from selling 50 units. So that's just P of 50. Substitute lang natin doon sa equation natin. Tapos makukuha nyo na dapat this equals 525. Hence, the manufacturer earns 525 pesos when 50 units are sold. Tignan naman natin paano kung dagdagan natin yung units na nabenta natin by 1. So, we get P of 51. Substitute again. So, upon calculation, you should get that this is 536.53. Therefore, the manufacturer earns 536.53 when 51 units are sold. So, ano yung na-illustrate ng dalawang functional value ng profit natin dito? Okay. So, it will tell us the profit earned in selling the 51st unit. To get that, you just simply subtract P of 51 minus P of 50. And that equals 11.53. Okay. And using this illustration, we will define the marginal cost, marginal revenue, and marginal profit. So, pag sinabi nating marginal of a function, you just get the derivative. Since again, that is just the rate of change. So, the marginal cost is dc over dx, the marginal revenue is dr over dx, the marginal profit is dp over dx. So, all of the functions are differentiated with respect to x, or the number of units. So, pwede rin ganito yung notation. So, pwedeng c prime of x, r prime of x, and p prime of x. So, this marginal functions would be the rate of change of the function when x equals n. And this is an approximation of f of n plus 1 minus f of n. So, kung babalikan natin yung problem natin earlier, so balik tayo doon. Instead of solving the actual P of 51 minus P of 50, we can just get the marginal profit at x equals 50. So, that will be P prime of 50. So, that means you can get the additional profit in selling the 51st unit by just simply computing for P prime of 50. Okay? Okay, so sige, gawin nga natin yon. We have the same function as earlier. And getting the derivative of this, will get 0.006 times 3 lang yung constant, x squared plus, here we have 10. Okay? So we have to get P prime of 50, substitute again here, and if we calculate this, this equals 11.50. So this is very close to our actual value, which is 11.53. Hence, this is an approximation of the actual gain in profit by increasing the production level from 50 to 51 units. Okay. So let's move on to this example. We have a company manufacturing fuel tanks for automobiles. The total weekly cost in dollars of producing X tanks is given by this function. C of x equals 10,000 plus 90x minus 0.05 x squared. First, we find the marginal cost function. So again, when we talk about marginal cost, that means you're just gonna get the derivative of your cost function. So getting c prime of x, or dc over dx, equals the derivative of the constant is 0, plus the derivative of 90x is 90, and the derivative of 0.05x squared is 0.05 times 2x. Simplifying this, you have 90 minus 0.1x. Okay? So this will be the marginal cost function at any value of x. Next will be to find c prime of 500 and find the exact additional cost of producing the 500 first tank. Substitute natin ang c prime of 500 equals 90 minus 0.1 x. Our x is 500. So that equals 90 minus 50, or equals $40. And yung second instruction is to find the exact additional cost. So since you want the exact, we're going to use the original c of x. Okay? So that's c of 501 minus c of 500. Katulad ng ginawa natin kanina with the profit of producing the 51st product. So c of 501 is this one. So substitute lang natin. Okay? So verify nyo na lang na this should equal 42,539.95 At ang C of 500 natin, pag plug-in natin, will be equal to 42,500. Subtracting the two, you'll get 39.95. So this is the exact additional cost of producing the 500 first product, which is close to our C prime of 500, which is equal to $40. Okay? So as we can see, our C prime of 500 is a good approximation of C of 501 minus C of 500. Okay, we have a new example. A fast food restaurant has determined that the monthly price demand function for their hamburgers is given by P of X equals 60,000 minus X divided by 20,000. X here is the number of hamburgers sold. We want to find the increase in revenue per hamburger for a monthly sale of 20,000 hamburgers. Okay? So dito we are looking at the rate of change of the revenue. So we want to get the revenue function. And recall natin, how do you get the revenue function? That is just equal to the total number of units times the price per unit. So, plug in lang natin ang small p of x. You have this. Okay. Simplify lang din natin. You can multiply x to both of this and then divide 20,000 furthermore. So, dito sa ating first term, magkakaroon tayo ng 60,000x divided by 20,000. Pag dinivide nyo yan, magiging 3 lang. So, we have 3x here. And then, if you multiply x here, you have negative x squared all over 20,000. So, this is our revenue function. We want to find the increase, so the rate of change. So, you're gonna get the marginal revenue. That's R prime of x. That equals 3 minus x over 10,000. So, this is just the derivative of our R of x. And we want to get specifically the rate of change at x equals 20,000. So that will be 3 minus 20,000 divided by 10,000. So we have 3 minus 2 equals 1. Okay? So the marginal revenue for the sale of 20,000 hamburgers is 1. So this is our last example for the first part. Summarize lang natin, we have 4 functions here. We have C of x, which is the cost function, R of x, which is the revenue function, big P of x, which is the profit function, and small p of x, which is the price demand function. The 4 are related by the equation. The profit function P of x equals the revenue minus the cost, that's R of x minus C of x. But moreover, since the revenue is equal to the number of units times the price per unit, the profit function is also equal with x times small p of x minus C of x. Moreover, if you want to approximate the additional cost, revenue or profit of producing the n plus 1 product, then you can just get the f prime of n. That would be approximately equal to f of n plus 1 minus f of n, which is the actual cost, revenue, or profit. Okay, now we move on to the second part, which is related rates. Okay, so we consider this problem. This is an example of a related rates problem. A water is flowing into a conical tank at the rate of 5 cubic meters per minute. The cone has altitude 20 meters and base radius 10 meters. The vertex of the cone is facing down. How fast is the water level rising when the water is 8 meters deep? Okay, so if you try to calculate this problem using related rates, you'll get this answer. When the water is 8 meters deep, the water level is rising at the rate of approximately 0.099 meters per minute. So that means you can actually get the rate of change of the water level using the rate of change of the volume or the amount of water flowing into your conical tank at a certain height, which is in this case 8 meters deep. So, yung information natin dito, this will give us an idea of when the tank will be filled to capacity. And this will be useful, especially, for example, in this case, the tank is part of the overflow system of a dam. Okay? So, ito yung isang significance ng related rates. Okay? Yung mga gantong types ng problems, meron tayong related quantities that changes with respect to time. Okay? And we can solve this using derivatives. So that means pwede nating mahanap kung gaano nag-i-increase or nagdi-decrease ang isang quantity based nga sa rate of change ng isang related quantity sa kanya, both of them ay with respect to time. Okay? And again, since we're talking about rate of change, we're going to use derivatives here. Okay? So if you have a quantity x that changes with respect to time t, then the rate of change is given by dx over dt. Okay? So kung quantity y naman yan, that will be dy over dt. If that's a, then dA over dt and so on. Okay? And the best way to fully understand this topic is to actually solve problems on related rates. Pero bago yon, let's list first some steps in solving problems on related rates. This will be helpful and this will guide us later on kapag sinasolve na natin yung mga exercises. Yung first step natin is to draw a figure if possible. This is helpful for us, especially if you want to look at the movement of the variables because that will affect the sign of your rate of change. Moreover, maganda rin na madrawing natin para makita natin yung overview ng situation. For the second one, we define and write an equation that relates the variables. And since most of the time, we're talking about the rate of change of a variable with respect to time, we let t denote the time. So sa step na to, kakolect natin lahat ng variables involved and we write an equation that relates all of them. For the third one, we write down any given numerical facts about the variables and their derivatives with respect to t. A reminder ko lang sa dito, not all the time explicitly given tayo ng lahat ng variables and derivatives na kailangan natin. So sometimes you have to solve and analyze to get the other variables. So you can solve that using some properties or theorems. For the fourth one, we differentiate the equation with respect to t. And the last step would be substitute the values of known quantities and solve for the desired quantities. So, dito important na for the whole process, alam nyo kung ano yung target nyong isolve na quantity. Okay? Because that's what you're going to solve for the last step. Okay? So here, naka-highlight naman yung mga keywords para mas madali nating tandaan at ilagay din natin siya sa gilid para guide sa atin later on. So we have again draw, equation, given, differentiate, substitute, and solve. Right? So illustrate natin yung process using this simple example here. We have two variables and x and y, both differentiable functions of t, and they are related by this equation y equals x squared plus 3. Ang hinahanap natin ay, emphasis on this, dy over dt when x equals 1, given that dx over dt equals 5 when x equals 1. Okay? So, yung first step ay to draw, pero hindi natin kailangan ng drawing dito, so we skip that part. Also, yung second one, we don't need to do that because given na sa atin yung equation that relates x and y, which is this one, y equals x squared plus 3. Okay? For the third one, ano ba yung mga given sa problems? We have x equals 1 at ang corresponding dx over dt at that point ay equals sa 5. Okay? So, now we differentiate this expression with respect to t. Take note, we're differentiating with respect to t So, ang derivative ng y ay dy over dt, right? Ang derivative ng x squared, sorry, ay 2x. So, you have this. But again, we're differentiating with respect to t. So, kahit x yung differentiate natin, we will put dx over dt. Okay? And the derivative of plus 3 is just 0. So, ito yung magiging result once we differentiate this function with respect to t. Next is we substitute yung mga given kanina, x equals 1 and dx over dt equals 5. So, question, kailangan pa ba nating mag-solve ng iba pa? Okay. Tingin tayo sa equation, no? Ang kailangan natin ay dy over dt. So, kailangan natin ng x at dx over dt. So, okay na dahil meron na tayong given sa dalawang ito. Substitute lang natin, dy over dt equals 2 times our x is 1, our dx over dt is 5, which equals 10. Okay? So, sa example na to, kita naman natin na ang x and y is related by this one. At kapag given ka ng rate of change with respect to time at a specific x here, makukuha natin yung corresponding dy over dt or rate of change of y with respect to t. Hence, the rate of change of x and y in this case are related to each other. Okay? Now, let us start solving our examples. For number 1, we have a pebble dropped into a calm pool of water, causing ripples in the form of concentric circles. The radius r of the outer ripple is increasing at a constant rate of 1 feet per second. When this radius is 4 feet, at what rate is the total area A of the disturbed water changing? Okay? Sige, analyze nyo muna yung problem. Okay? So, dito sa problem na to, ito na yung illustration natin. So, basically, you have concentric circles. But in our problem, ang variables lang na concern tayo would be the radius r of the outer ripple and yung total area A of the disturbed water. And yung total area A natin would basically just the area of our outer ripple. So, we have this. So, let R be the radius of the circle and A be the area of the circle. So, yung second step natin will to get an equation that relates A and R. So, we're talking about the radius and area of a circle, then we can use the formula for the area of the circle. So, we have this, A equals pi R squared. Then, we list the given. Ang first given natin will be dr over dt equals 1. Sabi dun sa problem, the radius of the outer ripple is increasing at a rate of 1 feet per second. So, since increasing siya, therefore, our rate of change for the radius is positive and is equal to 1. And ano yung hinahanap sa problem? We are asked to find the rate of change of the total area, that's dA over dt, when r equals 4. Okay? So, ito yung summary ng given at kailangan nating hanapin sa problem. Next step would be to differentiate our equation, a equals pi r squared. Okay? So, ang derivative ng a with respect to ti, ang derivative ng a ay 1, but by chain rule, we put dA over dt. And then, here, we have pi. Copy lang natin. Ang derivative ng r squared ay 2r. And then, we put, again, dr over dt since we're differentiating with respect to time. So, ang hinahanap again natin ay dA over dt. Ang kailangan natin ay r at saka dr over dt. So, enough na yung information natin from earlier. We are good to substitute kasi meron na tayong r at dr over dt. Hence, substituting the quantities, we have d over dt equals pi times 2 times our r is 4, dr over dt is 1. And hence, we get 8 pi. So, we have the conclusion that The total area of the disturbed water is changing at the rate of 8 pi feet square per second. Okay, so in this problem, we are relating the rate of change of the radius of the outer ripple with its total area. Okay. For number 2, we have a ladder 25 feet long leaning against a vertical wall. If the bottom of the ladder is being pulled horizontally away from the wall at 3 feet per second, how fast is the top of the ladder sliding down the wall when the bottom is 15 feet from the wall? Okay, so analyze nyo muna yung problem. Okay, so the first step in solving this problem is to draw the illustration. So I have here a ladder that is leaning against a wall. So let's say this is the wall. Then we can illustrate this as this. Okay, so now this is our ladder, and this is the wall. Okay, and ang una natin gagawin is to identify kung ano yung mga quantities na changing at ano yung mga quantities na hindi nag-change. That means constant, because for the quantities that are changing, we will let a variable for that. Start tayo with this side. So ang side na to is technically the length of the ladder. So take note that no matter how you pull the ladder horizontally away, the length will not change. So constant ang length na to, constant ang length ng ladder, that is 25 based on our given. Tapos, how about this side? So, nagbabago ba tong side na to? Of course, because your ladder is being pulled horizontally away from the wall. Okay? So, ito ay nagbabago. We let this as x. Okay? So, how about tong side na to? Nagbabago ba siya? So, tignan natin, no? If you pull this horizontally away, so, ibig sabihin, nag-move yung ladder natin to the right. Kung mapapansin nyo, dapat bababa yung wall natin. So, parang magiging ganito, no? Pag pinul ko siya horizontally to the right. Okay? So, therefore, nagbabago din ang height ng ating ladder. And we let this as y. Okay? So, this is y. And this is our x. So, moreover, describe na din natin yung motion ng ating ladder. So, yung ladder natin is moved to the right. Okay? So, that means yung x nga natin ay nag-i-increase. Okay? And we have the given that dx over dt is equal to 3. It's positive again because the x here is increasing. Sa y, hinahanap nga natin kung gaano kabilis is the top of the ladder sliding down the wall. So, we're talking about the change in y. Ang hinahanap natin ay yung dy over dt. And you should expect that that will be negative because you're sliding down. Okay? So, that will be the direction of your y. Okay? So, this will be the illustration of our problem, which is also this one here. Okay? So, yan. Again, let y be the distance from the ground to the top of the ladder at time t, and x be the distance from the bottom of the ladder to the wall as illustrated in our drawing. So, yung second step natin will be equation. What could possibly relate x and y? Tignan natin ang diagram natin. This is a triangle. Specifically, this is a right triangle, so we can relate the sides using the Pythagorean theorem. Okay. So we have here x squared plus y squared equal the square of the hypotenuse, that's just 25 square, which is 625. Okay, so this will be the equation that we are going to work on. For the third step, we list all the given. Okay, and ilista rin natin kung ano yung hinahanap sa problem. So, nasa diagram na rin natin to. Since the ladder is being pulled horizontally away from the wall at 3 feet per second, your dx over dt equals 3. And you have to find dy over dt. Okay, given that the distance of the ladder to the wall is equal to 15. Okay. So, here are the given and the unknown. Yung next natin will be the fourth step, which is to differentiate. So, differentiating 1, ang makukuha natin ay ang derivative ng x squared ay 2x times, we're differentiating with respect to time, so dx over dt. Ganon din yung y squared, no? Plus 2y dy over dt equals, ang derivative ng 625 ay 0. Okay? So, we have this equation. Tapos, again, emphasis on this, we're looking for dy over dt. So, we solve dy over dt in terms of the other variables, which is this one. Okay? So, ang gagawin lang natin dito, transpose lang natin yung 2x dx over dt, right? And then, divide everything by 2y. Okay? So, you should get this dy over dt equals negative x over y dx over dt. Tingnan natin tong equation na to. Ang hinahanap sa atin ay dy over dt again. Ang mga kailangan natin para ma-solve to ay yung x, which is given to us. Yung y ay hindi given. Yung dx over dt ay given. Okay? So, dito, hindi pa tayo magsa-substitute kasi kulang pa tayo ng isang variable, which is yung y. And, ang gagawin natin para makuha yung y ay to use the Pythagorean theorem. Okay? So, take note that when x equals 15, by Pythagorean theorem, magkakaroon tayo ng 15 square plus y square equals 625. Okay? Then, solving for y, that will just be square root of 625 minus the square of 15, which is 225. And equal siya sa square root of 400, which is equal to 20. Okay? So, ang ginawa lang natin dito, kinuha natin yung value ng y when x equals 15. And we use the Pythagorean theorem. Okay? So, now, meron na tayong x, y, dx over dt. Substitute na lang natin. So, nakuha natin. Our dy over dt equals negative x, 15, divided by y, which is 20, times our dx over dt, which is 3. And hence, we have dy over dt equals negative 9 over 4 feet per second. So, again, tama na negative siya because your ladder is sliding down. Hence, your y is getting smaller and smaller. We have the conclusion that the top of the ladder slides down the wall at the rate of negative 9 over 4 feet per second. Number 3, air is being pumped into a spherical balloon at the rate of 4.5 inches cubed per minute. Find the rate of change of the radius when the radius is 2 inches. Okay? So, analyze the problem first. Okay? So, ito yung illustration natin sa problem. Tignan natin kung ano yung mga variables involved here. We have the volume, okay, because we are talking about the air being pumped inside the spherical balloon. So, the volume is getting bigger. And also, we have the radius of the sphere, okay, of the spherical balloon. Okay, so ang hinahanap sa atin dito ay yung rate of change of the radius, that's dr over dt. Right. Second is to relate the variables. Again, we have two variables, r to be the radius of the balloon and v to be its volume. And we're talking about the sphere, so we can relate the volume and the radius by the formula for the volume of the sphere. Okay? So this is the volume of the sphere. You have V equals 4/3 pi r cubed. So again, yung mga given sa problem, ang volume is increasing at the rate of 4.5. Therefore, our dV over dt is positive, and this is equal to 9/2. So, ano lang no, ginawa lang natin fraction yung 4.5. Okay? And our goal is to solve, again, dr over dt when your radius is equal to 2. Okay? Next step would be to differentiate. Okay? Differentiating this equation, we'll get this dv over dt, that's the derivative of v. So we copy 4/3 pi, that's just constant. The derivative of r cubed is 3r squared. And then we put dr over dt. Okay? And take note, we are solving for dr over dt, so we rearrange this formula in such a way that we have dr over dt equals something. Okay? Pero bago yon, ayusin muna natin yung right-hand side. Yung right-hand side, pwedeng mag-cancel out yung 3 dyan. Okay? So, simplifying that, we'll get dv over dt equals, yung right-hand side magiging 4 pi r squared dr over dt. Then, solving for dr over dt, pwede nating i-divide both sides by 4 pi r squared. So, ibig sabihin, bababa lang yung 4 pi r squared. Okay? So, finally, we have dr over dt equals 1 over 4 pi r squared times dv over dt. So, let's look kung ano yung mga kailangan natin. Kailangan natin ng r, which is given, r is equal to 2. At kailangan din natin ng dv over dt, which is given, which is equal to 9/2. So, we are good to substitute. So, substituting, we have 1 over 4 pi times 2 square. So, magiging 1 over, sa baba, mayroon kang 4 times 4. So, 1 over 16 pi times 9/2, which is our dv over dt. That will just be 9/32 pi. Okay? So, therefore, our final answer would be the rate of change of the radius is given by dr over dt equals 9/32 pi inches per minute. So, observe din natin na yung dr over dt natin ay dapat nga positive kasi nag-i-increase yung volume natin. Okay? So, therefore, here, we are relating the rate of change of the volume and the rate of change of the radius of the spherical balloon. Okay? Now, for our last example, we have a man, 5 feet tall. He is walking at a rate of 6 feet per second towards a street light which is 20 feet high. So, you refer to the figure below. So, this will be our illustration. At what rate is the shadow length changing? Analyze first our problem and also the diagram. Okay? So, define natin yung mga variables. We have here x to be the man's distance from the street light. Okay? So, nagbabago to, kaya tayo nag-let ng variable. Also, yung length ng shadow, which is L, ay nagbabago. So, we let that as L. Right? So, meron tayong dalawang constant quantities dyan, which is yung 5. That's the height of the man. It doesn't change. And also, the height of the street light remains constant. Okay? So, looking at our diagram, how do we relate L and X? Okay. In this diagram, you can see two triangles here, right? We have the bigger triangle and the bigger triangle with dimensions of the base L plus X and height of 20, and the smaller triangle with the base L and height of 5. Okay? And in this case, we can actually use similar triangles. Okay? So, ano ba yung property ng similar triangles? Ibig sabihin, yung proportion or yung ratio ng kanilang sides ay equal. Okay? So, if we look at the ratio of the sides, we have, for the bigger triangle, we have 20 divided by L plus X. This is the left-hand side. Dapat equal siya doon sa corresponding dimensions ng ating smaller triangle, which is 5 divided by L. Okay? So, this will be our equation that relates L and X. Now, you can leave the equation as is this one. Pero, if you can simplify your equation, then that would be better para mas madali tayong makapag-differentiate. So, yun yung gagawin natin. Simplify muna natin to. Okay, para mawala yung mga denominators. So, what we can do is we can cross-multiply. We have 20L equals 5L plus 5X. Moreover, I can move the 5L to the left para mapag-combine sila. You have 15L equals 5X. Pwede nating i-divide both sides by 15 so that I will have something like L equals 5X over 15, which is 1/3 X. Now, as you can observe, this equation is much easier to work with instead of this one. Okay? So, if you can simplify your equation, then do it. Next are the given to us. We are asked first to find the rate of change of the length of the shadow. So, that's dl over dt. Tapos, given tayo ng quantity na dx over dt equals -6. So, bakit siya negative? Negative siya kasi yung x natin lumiliit siya, right? Kasi yung man natin ay approaching the street light. Therefore, yung distance niya from the street light will go smaller and smaller. That's why it's -6. So, ito yung sinasabi ko kanina, it is important that you have the diagram para makita nyo kung positive or negative din yung mga derivatives natin at yung mga rate of change natin. Okay? So, now that we have the given and the unknowns, we can differentiate L equals 1/3 X. That will just be the derivative of L is just dl over dt, and the derivative of 1/3 X is just 1/3, and then we multiply dx over dt. Dito, ang kailangan lang natin ay dx over dt, and we're good because we already have that as -6. So, we have 1/3 times -6, so that's just -2. Okay? So, the shadow length is changing at a rate of -2 feet per second. Okay, so negative siya, tama, because as the man goes nearer to the street light, then yung shadow niya ay umiikli. Okay? So, here we relate the rate of change of the distance of the man to the street light to the length of the shadow. Okay? So, this is our last example. These are more exercises for you to practice on. So, importante dito na talagang mag-solve kayo ng mag-solve, especially on the related rates problems, because it takes so much practice para mag-grasp nyo yung full concept at masanay kayo sa pag-solve ng mga ganitong types ng problem. Okay? So, that's it for this lecture video. I hope you understand and nakasabay kayo sa ating discussion. Bye!